So we established that charges interact with the forces over the distance, and what we say is created when the object interacts without being in contact. Field. There is electric field. So if you have electric charge, it creates electric field around it. And how they interact, what the magnitude of their interaction. And there is a law describing this interaction, Coulomb's law. That's why the unit of charge called Coulomb, because in honor of the person who discovered that law and with a mathematical formula to the force of the interaction between electrical charge. So if you have two charges, let's say two positive charges, Q1, charge reminding from unit 1, the charge for charge we have using letter Q, either capital or lowercase. This is Q2, and let's say it will be positive, and the distance between them is R.
Is it from the middle?
We consider the charges that don't have any size. They are point charges. So it's not like with the gravity, we had to take from the center of the planet, measure distances. We take the charges that they don't have any size. They have just a point. And the formula is F equal K times Q1, Q2 over R squared. It's very similar to what?
G and R squared.
To the formula of the law of the gravity. It's the same mathematical relation, inverse square law. But where is the significant difference? In the law of the gravity, the coefficient was 10 in negative 11. K in the Coulomb's law equal 8.99, or we will be using in calculations 9 times 10 in the power positive 9. So it's 20 orders of magnitude bigger. That's why electric force is so much stronger than gravitation. For gravitational force, you need huge masses to have the force of the interaction visible. For electric, no. Let's go, yes?
What are the units for K?
Units for K are, if this is newtons, this is Coulomb times Coulomb squared, this is a meter squared. So if you rearrange this formula for K, thank you for excellent question. K will be equal from here, will be F times R squared divided by Q squared, if charges are same. So the unit will be newtons times meter squared, Coulomb negative 2. That will be unit for K.
Is the C capital or lowercase?
Capital. As same as N, because it's synonym. Newton, Coulomb. Meter is not synonym, so it is lowercase, like that. C and N letters. And K depends on the medium. We're not considering, in this course, we're not considering this effect, but this number is for empty space, for vacuum, or for air. In air, it's pretty much the same. But if, let's say, if charges will be in the water, or they will be inside of some other medium, let's say, inside a glass, inside something, K will be different. It's affected by the properties of the medium, but that's beyond our course, so we should not worry about that. We will have always K as a constant. So let's calculate what will be Coulomb. One Coulomb is a big charge or small charge? Who remember, I don't expect you to remember, but just who remember what is the charge of the electron QE?
Fine, right? It is small, but negative.
1.6 times 10 negative 19 Coulomb. So 1 Coulomb, how many electrons we need to make 1 Coulomb of charge? We divide 1 over 1.6 times 10 in the negative 19. That will be approximately I can use the calculator. I think it will be something like around 6.8 times 10 in the power 18. Can someone check with the calculator?
6.2.
6.25 times 10 in the power 18, yeah? 6.25 times 10 in the power 18. So we need to have quite a lot of electrons to make 1 Coulomb of charge. So 1 Coulomb is
6.25 times 10 to the power of 18 what?
electrons.
Yes.
Electrons. Charges of so that many electrons we need to have. This no. This now no. And this, it is on the formula sheet. Plus, we over the course will be using it so many times that you will remember it. Like someone wake up in the middle of the night and ask what charge of electron, say 1.6 times 10 negative 19. Even though without putting any efforts to memorize, you just will be using it a lot. But it is on the formula sheet, so you don't have to memorize. Now let's calculate what will be the force of the interaction between the, let's say, nucleus of the hydrogen atom with its electron. The nucleus of hydrogen atom is just 1 proton. So we have 2 charges, they both 1.6 times 10 negative 19, and the distance between them, let's say approximately that r, distance between the proton and electron in the hydrogen atom, let's say 1 times 10 in negative 10 distance. So, and charge of each of them is this, so let's calculate what the electrical force between them. So we have 9 times 10 in the power of 9 times 1.6 times 10 negative 19, and that's squared, over 10 negative 10 squared. That will be equal. That will be equal 1.44 times, we have 30 minus 18 times 10 negative 9, I think. Can you please check with the calculator? Can someone please check with the calculator? Yeah? Yes.
Why is the top one 1.6 times 10 to the negative 19?
This is the charge of electron.
Q1 and Q2.
And charge of electron is this, and charge of the proton. Hydrogen atom has 1 proton and 1 electron around. So charge of electron, same charge of proton. And have you checked? Is it correct?
I think it's
2.3
times 10 to the No,
2.3 times 10 negative there.
yeah, it's a negative
Sorry, number is 2.3.
Yeah.
I forgot about square. I multiplied by 1.6. 2.3.
Times 10 to the negative
8, yep. Newtons. Seems to be pretty small. But let's calculate to compare force of the gravitational interaction between proton and electron. So we have force of gravity equals 6.67 times 10 negative 11 times mass of electron is 9.1 times 10 negative 31 times mass of the proton. I don't remember exactly the number of the mass of the proton, but it is approximately something like 2, let's take it 2 times 10 negative
Should we write this down? as well?
20. This is an example.
Okay.
And the distance is the same, 10 negative 10 squared. If you calculate the force of the gravitational interaction between proton and electron, we will get something like around 1.3 times negative 11, negative 41, 68 times 10 in negative 40 again. Minus 48. I think something like that. Can you please someone check with the calculator if this is correct? 6.67 times 10 negative 11, 9.1 times 10 negative 31 times 2 times 10 negative 27 over 10 negative 10 squared.
1.2 times 10 to the negative 47.
One a little bit off. 1.2 times 10 negative 47. Can you see the difference in the electrical force 10 negative 8, gravitational between the same object 10 negative 47. That's how much electrical force is stronger than gravity. Example of the application of the Coulomb law. Let's say we have 3 charges. Which are positioned in the next way.
Yes.
How do you spell it?
Positive, negative, and another positive charge. This distance is, let's say, 0.5 meter. This distance is 0.4 meter. This charge is 5 microcoulombs. This charge is 4 microcoulombs. And this charge is 3 microcoulombs. And we need to find the resultant force on the middle charge. In which, so let's name them charge A, charge B, and charge C. In which direction charge A will apply force on B?
Right. To the left.
To the left. So it's applied to the left. Charge C?
To the right.
To the right. So how we can find overall?
Minus.
Minus. So overall will be F equal. We can take K as a common factor, 6.67 times 10, 6.67, 9 times 10 in the 9 times, and we can take, because this charge will be both types involved, so we can take this as a common factor, times 4. Micro means 10 in negative 6. 4 times 10 negative 6. And we have 5 times 10 negative 6 divided by 0.5 squared minus 3 times 10 negative 6 divided by 0.4 squared. Does that make sense why I've got this? This is K. This is this Q. Because we have K, Q, each of them K, Q times Q1 over R squared. For that will be Q2, but the middle, this charge is the same. It's interact with this and with this. That's why I take it as a common factor, middle charge. Make sense?
Yeah.
What about over R squared?
That's the different function.
This one,
Yeah.
distance between those squared, from this one over distance between those squares. Yes?
So if this is negative, that means it's equal to, right?
Hmm?
If this is negative, does that mean?
If this result will be negative, that means it will be overall to the right.
Yeah.
Yes?
Do we use 9 instead of 8.99 for calculations?
Yes.
So on here or not?
Yes, it is. On the formula show the formula sheet it is.
It's on the back.
It's 8.99.
So do we use 8.99?
So on the exam you use 8.99. I don't think it will make much difference.
Yeah, not.
Again, please have someone calculated.
4.5 times 10 negative 2
4.5
times
times 10 negative 2 newtons. Because it's positive, that means overall to the left.
I got negative 10. It's the negative 10.
Hmm?
Maybe I did wrong.
Alright, what did you get?
I got 4.5 times 10 to the negative 10.
It shouldn't be because this will be 10 negative 6 times 10 negative 12, 10 and positive 9. So yeah, this should be, this is right, 10 negative 12.
I mean, the bottom line is.
Make sense?
Yeah.
Another example.
Do you have to state the direction of the force?
Yes.
So should I just draw an arrow to the left?
Yeah, also say it left.
Okay.
Another example. We have no. We have 4 charges located in the vertices of a square with a side of a square, let's say half a meter. So each side is 0.5 meter. And we have, let's say, all charges will be the same, will be, to make it easier, will be positive, and will be positive 5 microcoulombs. Each charge is 5 microcoulombs, positive. And we have A, B, C, D. Question is, find the overall force on the charge D. Find the overall force on the charge D. We have that forces acting. Charge A on D pushing this way. Charge C on D pushing this way. Charge B on D pushing this way.
They're all positive.
Now that makes sense, they're all positive, so they all,
Wait, what was the question? The charge on D?
what is the force, overall force acting on the charge D? Yes,
Oh, wait, no, because they repel, that's why.
they're all positive. So they all push it away. But this push it that way, this push it this way, this push it that way. Now, what is the magnitude of force that C exerts on D? And it's same as A exerts. That is 9 times 10 in the power of 9 times 5 times 10 in the negative 6 squared over 0.5 squared. So that will be 9 times I got 0.9.
Yeah, that's correct.
Yeah.
0.9 newtons.
I got the same.
So, now, to find the force that B exits on D, we need to find this distance. How you can find this distance? Pythagoras or trigonometry, because all sides are the same. So this angle is 45 degrees, and we need to find hypotenuse when we have the side is 0.5. So we need to divide 0.5 by sine 45 degrees or cosine, which is the same, which will becomes 1 over root 2, which is about 0.71, I think. Can you check?
Should we
Yeah,
do
it's
Pythagoras?
Huh?
It is, if you round it, 0.71.
We can
Should
do
we do
Pythagoras.
Pythagoras because you need R squared anyway?
Yeah, we can do Pythagoras. It's same, but we know, look, this is a right angle triangle. This angle is 45 degrees. We have both sides need to find hypotenuse. It's same. You'll get it about 0.71. So we will have the now force that B exits equal 9 times 10 in the power of 9. We have same charges, 10 in negative 6 squared, divided by 0.71 squared, which will be equal,
0.5.
will be 4.5. Will be 4.5 times, that will be
No, 0.5.
will be 4.5, no, 0.45 newtons.
Yeah.
0.45 newtons. Make sense? Now, how we will find overall force?
Add
We need to add vectors. So, how we do it in physics? We resolve it into the directions. Now, in this case, pretty much we can do shortcut. We don't need to do all resolutions. Because clearly this is same as this, so their addition result will be in this way. And then to find overall, we just add these two and then add the third one. So what is the result of addition of these two forces? Using Pythagoras, we can find it using Pythagoras. We have, if this is 0.9, then resultant force. If we have 0.9 this way, 0.9 this way, the resultant we can find using Pythagoras, square root of 0.9 squared plus 0.9 squared. So we get a square root of 1.62. Square root of 1.62
1.27.
hmm?
1.27.
equal 1.27. So this force is provided by charge C, and A is 1.27 plus this one. So overall charge will be 1.27 plus 0.45 equal 1.72 newtons. Make sense how we did it?
Yeah.
Okay, that's
How would you say the direction?
and direction. You can state that direction from the horizontal. In this case, it's pretty simple, 45
Would
degrees.
you have to say like anti-clockwise or negative 45 degrees or something like that?
No.
Okay.
No. Okay, then that's all explanations for today. Like, subscribe and donate to help fight crazy Russian fascists. Support Ukraine and Israel.